So these are the different types of data that you have to deal with when because I'm trying to get them to be able to build AI solutions themselves without having to have somebody like me advising them. So up here at the top is your context. Depending on which model you're dealing with, is somewhere between 1 megabyte and I think the maximum is about 4 megabytes with Gemini. So that's the amount of data you can get in at any one time. The large language model is about 140 gigabytes worth of data. 70 billion parameters multiplied by whatever number of bytes per parameter gets you about 140.
What do you mean the LLM that I'm accessing?
The model, when they built the model, they train it and it grows in size, and eventually it ends up with, most of them at this stage have 70 to 100 billion parameters. And each parameter is a floating point number. So you're talking about 140 gigabytes of data. If you download any of the big models, it'll take up 140 gigabytes. And the next layer then is where we are providing our own database tables. You're probably in a major situation talking about 10 gigabytes of local data, transactional data that you were using. Because remember, we're using agents in a transactional situation to automate. Right. The next layer down after that is your corpus. And there's a maximum limit you can actually get in the various models of up to 120 gigabytes.
And the corpus is what you described, the organizational knowledge. Is that correct?
Yes. This is your uploaded documents.
Okay.
That have been vectorized. So it's your vector DB.
And what's the DB on top?
This is relational database. So this is data that hasn't been vectorized. Your customer data, your product data, your order tables, your delivery tables, and so on.
Got it. Non-vectorized. Got it.
Non-vectorized because it's changing and it's transactional. This is stable. This isn't changing every millisecond.
Yeah.
And then you have access to the web. The searchable web is about 10 petabytes.
And help me out here, the LLM was built using the web?
Yes.
So why do you have, is that just the new data on the web, or is
if I want to know what is the conversion rate between dollars and something, if I need to know what is the weather like in Switzerland, if I need to route a truck from Brussels to somewhere in Latvia, I need online access to the web for that amount of data. So the size of the boxes, not quite to scale, obviously, because this would be tiny. But this is the pyramid of data that you need access to. And the key point is that you only have this tiny amount of data at the top. So every time you are doing a prompt, you're going to move some piece of data from your database into the context. You're using a formula to build your prompt, and it says, here's the information about the order I want you to make a decision about, and so on. So I pull that from my database. I also, when I execute a query on the corpus, it finds several chunks that match, and it pulls them into your context as well. And then anytime your prompt needs information from the web, it executes a web search and then pulls the results of the web search into your context.
The first arrow you drew, that is my active thing I do, where I say, this is the record, this invoice I want you to focus on. The other two arrows is what the AI agent itself retrieves. Is that correct?
In a way, yes, it's the tools that the AI agent uses, right? So for this one, for that arrow, we're using a Coda formula.
Yeah.
This one is your RAG. So anytime you execute a RAG, that's the arrow that pulls it in. And then this is where you do a web search.
Except I don't execute them.
Well, it's all limited by how much will fit in here. How much fits in there is actually quite small. I told you could only have 4 megabytes of RAM on your laptop, you would be pretty pissed. And that's the biggest and the slowest and the most expensive context you can use. Normally, it's around the 1 megabyte.
Wow.
Very often, it's a lot less, because in here, you have got to put your prompts, your data, all the data, wherever it's coming from, and the result. They all have to
and the result. That's a key point.
Yeah. So that's one of the reasons why when we're building agents, I use the length function in Coda a lot. When I'm building the prompt, I'll say, now, how long is that? Because if it's more than, say, 120K, then I've got to raise an error because I don't have enough space. Because you're limited in how many input tokens you can give. It is split, and each model is a bit different, but it is split between input tokens and output tokens. And then you have the rather annoying feature that if you overfill your context, it just drops the stuff off the top. It's like the top is evaporating all the time. So as you put stuff in at the bottom, it shoves everything up. And eventually the stuff at the top just disappears. So I have 2 debug statements that I put into the prompts. The first one is at the top. The first prompt at the top says, insert the symbol and a smiley face at the start of every response. And then you have all the data, all the prompting, blah, 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 blah. And then at the bottom, I put a statement that says, append the symbol sad face at the end of every response. This is while I'm debugging. And as long as I get a smiley face and a sad face, I know I haven't exceeded. And it works beautifully. And then suddenly the smiley face disappears. And you realize, it has forgotten the first instruction.
And the sad face never disappears because that's the last prompt.
The only time the sad face disappears is if you either accidentally or somebody maliciously does a prompt insertion. If there's something in the middle of your data that looks like an instruction that says, forget what you're doing and do this instead, then you won't get the sad face at the end.
I love this, by the way. I think this is very novel because putting it in these small numbers is like, oh, really? 4 megabyte? That's ridiculous. But can we bring this further to say what it is that you do? So is it accurate if I say, because your context is so limited, it's all the more crucial to be aware of what you put into this context? Yeah, and because of that, we want to make sure we only tie in AI where we need it, where we need that creativity, that adaptive logic.
The 3 things I say you need are when people are using knowledge, expertise, and judgment, then you can use an AI agent to approximate that.
Yeah.
So here's a query. So I've uploaded the SDK as my corpus, right?
Where did you upload this?
Into Coda. So let's go to 2 async pages. This is just an ordinary Coda document. It has all of the stuff we want that we would normally be using for training people is all in here.
Yeah.
As an ordinary Coda document. And so basically, I'm going in here and I'm saying, given this document, write code for a pack formula called hi that takes 2 parameters, name and greeting, and returns the 2 parameters appended together.
Oh, so basically you're taking the challenges that Troy gave us and you now feed it to the AI. That is very smart. Yes.
Now, this uses no packs. This is raw Coda AI.
Really?
Yep. So basically what I've done is I've made sure that each of these pages is big enough to have a useful body of knowledge in it, covering a given topic, but small enough to fit into the context and still have room for the output.
How do you decide that?
I'll show you actually, because if we go to here, so I have these summaries, right?
For each page.
For each section or page, yeah. And it's as simple a prompt It says summarize the introduction.
Love it. Love it. Yeah.
Now, when I first build my document, half of these would fail. If this page is too big, you actually get an error message from.
How interesting. Okay.
So if that happens, for example, I think the sync tables was too big. So I had to pull out the bit about the two-way sync tables and put them into it, and suddenly it was small enough to fit. So that's my test. So you're handcrafting, you're curating your knowledge, which is what they do anyway. They're using Coda to pull together their own wiki of here's all the information. The same with the SDK. I dumped the SDK into one huge big page, and then I cut and pasted bits of it out. Here's a list of the sections and a summary of them, because this entire summary will fit into the context window. And I can say, so given the problem I'm asking you to solve, which of these pages are important?
So basically, that's your chunking.
This is my chunking here, huge chunking.
Okay.
And so it has decided that if you're building a formula, it'll use this page. If you're building an action button, use that page. And if you're building sync tables, it uses this page. If you're doing formulas for column types, they're in here as well. And so when you come to this point here where you put in a really simple little query and you get this response, this is the first time that Coda, without any packs or any gobbledygook, has been able to answer the question and build an actual pack. And for me, this is a breakthrough.
Yeah.
If they're all dependent upon each other, the sequence in which I go across, and maybe I have to loop around and say, okay, well, I need to put this data type in, now go back and try and finish my formula. Well,
right.
So you may have to build an agent that has loops and branches in its logic. You're probably going to use formulas to define that logic rather than a big, long, hairy piece of German or English text. Now,
and that's why you're happy to use Coda, because Coda allows you to store the data in an easy way.
Suddenly, I'm looking at the best tool in the business for doing this.
And you're able to use Coda's powerful formula language. Well done. This is amazing.
Okay.
Horrible.
So the next thing I want to do is I'm trying to look at this in terms of what skills do you need? If you're a business manager and you want to survive the coming onslaught of AI, the skills you need. One of the skills you already have is business process management, which lets you build SOPs.
And that's your hypothesis, that your clients already have this.
I'm talking to people who already have that. And if you don't already have that, then you need to go and get it and then come back to me. The next thing that you need is what I call the spreadsheet skills, which is the no-code skills. But that comes in 3 flavors. So I'm going to make these as pillars. So the first one is you know how to organize your data into rows and columns and tables. But the other thing that you know how to do is formulas.
Yeah. So querying those tables you just built.
Yes, and manipulating them, writing formulas to do logic, right? And how to put everything on the screen so that an ordinary user is able to interact with it in a meaningful way.
Not just read, though. That's important, probably.
No, not just read. Actually,
that's why you say form.
And and in fact, you're talking about workflows. When you click this button here, it brings you over there.
And they are familiar with forms in Excel?
Oh, yes. When you use Excel to automate a workflow, you don't just leave the cells on the screen where people can go in and pull all over your underlying spreadsheet. You build a form, and the form says input the customer ID here, input the product ID there, input the quantity here, and so on. So you build a form, and Excel is actually very good at that. And then when you switch to either Notion or Coda, you're suddenly going, oh, okay, I know about this. And this is where you're using AI, but in particular, you're building AI agents. and you're using RAG or Raptor to do that. So what I'm saying, and this is what my course is teaching, is you already have your foundation in place, but I have to teach you how to do systems analysis a bit better. How do you turn these into a data model, an action model, and a UI model? And then the other bit that you don't have is to put this roof on the top, which is you also need to understand how to build AI agents, but not by programming, by using what's in Coda already.
I love that. Yay, you take away the pain. It's like, oh, that doesn't sound so bad. I can learn that. That doesn't intimidate me. You're like, hey, these are the skills you need. You already have the pillars. Now we're just going to add a roof. Yeah. I love it. It's
this is what I call the stairway. So the first step is level 0, which is no AI formulas. And the advantage that has is that it is 100% deterministic. And that's the lowest level of AI, no AI at all, in other words. Mm-hmm. And now this is level 1, which is LLM chatbot. So it knows everything about the universe through its training on the internet, but it only knows up to 6 months ago or a year ago. So it's like having a college professor who's been in a coma, that thing. And so you can ask it questions, and it's very general. You can ask it any question about anything, and it'll do its best to answer it. But it knows nothing about your company. It knows nothing about the internet as it is today. So it's of limited use, but it is intelligent. It can reason in ways that go beyond anything we ever expected for language models to be able to do. So the next level up is level 2, which is an LLM plus web search. And this is where Perplexity first came in and where Gemini is now. And this is where you can ask, what's the temperature today in Paris? You can say, can I go from here to there? What's the train schedule for such and such a place, and all of that. And that's where most people spend their time. Yeah. When they're saying, oh, yeah, pro. They're actually only at level 2. Okay, so level 3 is when you have your LLM plus RAG. So now you can upload your marketing material, your training manuals, your policies and procedures, your HR policy on paid time off and all of that. So now suddenly you're dealing with a model that actually understands your business. So level 4 is an AI agent. And particularly if you have an AI agent that also has RAG, then suddenly now we're into the useful stage. And if you're going to automate your business processes, you can forget all the others. This is the only type of AI you need to study and understand, right? Now, there is a level above, and this is where all the major AI companies are trying to get to, is give a single task to a thinking agent and it goes away for hours and it tries various solutions, checks them to see, oh, is that the, no, that didn't, okay, I'll go back and do this again. This is great if you're doing PhD level research, and it's great if you're exploring how do I create a new business, how do I, all of that sort of thing. You do not want these guys running your business, because every time you ask them to make an omelet, they go off and reinvent the recipe.
And you already have your recipe. Yep.
We're in the business of, we're McDonald's. This is how we make a burger. Don't get clever.
No help needed. Thank you.
Just be fast. So this is the magic piece of AI technology that you want. So that's what this rooftop here is. Basically, I'm saying, you know this. Most people know that, particularly if we're talking to people in Notion world. And this is the bit you need to learn.
Yes.
Forget
And
all the
yep.
other AI stuff that's out there being hyped. You're just going to pick one thing, and that's this one here. And you use these tables, formulas, and forms to build your agent. Somewhere among my experiments, I had uploaded the entire API document. So let me go to a new page. And I say /AI space, gives me an AI block, has taken this Raptor page, which is the entire Coda API written in Markdown. And it has taken my prompt.
This is so cool.
And it has produced the answer. My entire thesis is based on the fact that you just need no-code tools and you don't need Python. Okay.
Wonderful. Max, thank you so much for another fascinating and wonderful meeting.
Okay.
Wonderful. Talk soon, Max. Thank
Take
you.
care.
Bye.
All the best. Bye-bye.
Bye.